behind me is Bob Lindy. He's one of the best carburation and ignition men I've met in a long time. Weekdays from 8 to 5, he's the tune-up expert at Stateside Motors. 2 nights a week, you'll find him right here at the local high school teaching an adult education course on carburation and ignition. I'd like to have you all hear what he has to say on the subject of ignition system analysis.
Thanks, Tech, and feel free to sound off if there's anything you want to add to what I have to say. You can't do an expert job of diagnosing and correcting ignition system problems unless you know what the ignition system is supposed to do, why it's supposed to do it, and what happens when it doesn't do what it's supposed to do. What does the ignition system do? It boosts the low voltage available at the storage battery to the high voltage needed at the spark plug to fire the air-fuel mixture in the combustion chamber. But that's only part of the job. The ignition system must also control the timing of the spark for the best performance under all operating conditions. The ignition system is divided into 2 distinctly separate circuits. The low voltage or primary circuit starts at the battery and includes the ammeter, ignition switch, ballast resistor, primary winding of the ignition coil, the condenser, the distributor contact points, and the necessary connecting wires. The secondary or high voltage circuit begins at the secondary winding of the ignition coil and includes secondary ignition cables, the distributor cap, the rotor, and the spark plugs. Once you understand the function of each of the ignition system components, as well as the possible malfunctions of these units, you'll find it a lot easier to diagnose ignition troubles. So let's go through the system, 1 unit at a time. The battery is the source of electrical power for cranking the engine and operating the ignition system. It also provides the power for the lights and electrical accessories. There are 4 common causes of battery trouble: a cracked case or cover, continued undercharging or overcharging, neglected maintenance and service, and an undercapacity battery. Whatever the reason, a battery in poor condition will cause starting and ignition problems. Battery testing and service is the subject of another session in this series. However, the battery should be inspected and tested as part of every tune-up or ignition job.
I'd like to put in a word here. Don't take battery condition for granted. There's no excuse for not testing. With a wide variety of battery test equipment available, the only question is, which one to use? What's your choice, Bob?
I stick to the hydrometer and specific gravity readings as the logical starting point, Tech. If the specific gravity of all cells is 1220 or higher, the state of charge is okay. If there's less than 25 points difference between cells, the battery is probably serviceable. Next, let's consider the coil. The ignition coil increases the low voltage available at the battery to the high voltage needed to jump the gap at the spark plug. Under actual operating conditions, the output voltage is determined by the amount needed to cause the spark to jump the plug gap. This varies from about 5,000 at idle to about 15,000 volts at higher speeds. However, under open circuit conditions, the secondary voltage may go as high as 25,000 volts.
And let me warn you, don't crank the engine with secondary coil cable disconnected. The high open circuit voltage will damage the coil. If you want to keep the engine from starting when it's cranked, disconnect the primary wire from the distributor side of the coil. Using a jumper to short out the primary can overheat the coil. Disconnecting the hot coil lead can cause fireworks.
Speaking of coil connections, the coil must be connected for the correct polarity. Battery to the plus terminal, distributor to the minus terminal. Here's why coil polarity is so important. The spark jumps the gap at the plug more easily when the electron flow is from the hotter center electrode to the cooler ground electrode. Reversing the coil leads causes the spark to jump from ground to center electrode, and this may require as much as 40% higher voltage.
Here's a clue to wrong polarity. If you're using an oscilloscope and the pattern's upside down, check the primary connections at the coil. Either these connections are reversed or the oscilloscope isn't hooked up right. Actually, there's no excuse for incorrect connections at the coil, but it does happen.
I'm afraid it does, Tech. Now, a special ballast resistor is connected in series in the primary circuit. It limits voltage at low speeds but allows an extra margin of ignition voltage for high-speed driving. Limiting low-speed voltage increases ignition contact life and lowers coil operating temperatures. Don't try to cure an ignition problem by using a bypass or jumper around the ballast resistor. You may get a hotter spark at low speeds, but the ignition points won't last very long. On the subject of ignition spark, spark intensity provides a quick clue to possible ignition troubles. Simply remove a plug cable from one plug, stick a conductor into the terminal, and hold it about 3/8 of an inch from a good ground. Crank the engine and observe the spark. If the spark is very weak or won't jump a 3/8 gap, I know I have ignition trouble, and I check it out starting with the primary circuit. On the other hand, if the spark is good and jumps the gap easily, the basic ignition system is probably okay. If the complaint is hard starting or amiss, I check the spark plugs, secondary cables, and the fuel system. Next, let's tackle the condenser. The condenser does two things. It helps the coil develop higher voltage because it speeds up the collapse of the magnetic field when the ignition points open, and it reduces arcing across the ignition points.
The only sure way to test condenser capacity is with a condenser tester. Now, let's hear what Bob has to say about circuit resistance.
High resistance anywhere in the primary circuit will reduce voltage available and cause ignition problems. I guess every technician has his own pet way of checking circuit resistance. The important thing is to make sure both the ignition start and the ignition run are okay. Here's how I go about that. If the battery is charged and voltage at the ignition switch side of the ignition coil is 9.5 volts or higher when cranking the engine, the start part of the ignition circuit is okay. If cranking voltage is lower than 9.5 volts, the trouble is probably in the starting motor, or it is high resistance in the primary ignition circuit. To check for resistance between the battery and the ballast resistor, connect a voltmeter across the circuit from the battery to the ignition switch end of the ballast resistor. Also, disconnect the voltage regulator lead to eliminate current flow in that circuit. With ignition on and points closed, the voltage drop shouldn't be more than about 0.4 of a volt. If the drop is greater than that, leave the voltmeter hooked up and check out the connectors in the circuit. The easiest way to quick do this is to wiggle each connector and watch the voltmeter. If the needle jumps, you've located a trouble point.
Don't forget the ignition switch. Turn the switch off and on several times. The meter should come back to the same reading each time. For good measure, wiggle the key a bit. This shouldn't make the voltmeter needle jump.
That's an old trick, Tech, but it's a good check for a faulty switch. Next on the program is the distributor. It has two basic functions: to close and open the primary circuit so a high voltage will be induced in the ignition coil and deliver the high voltage to the spark plugs at the right time. Let's consider ignition timing. Ignition timing requirements depend upon engine speed and the load on the engine. And of course, engine speed and load change every time the driver moves the accelerator. That's where the centrifugal and vacuum advance come in. As engine speed increases, the time available to burn the mixture in the cylinders decreases. The centrifugal advance mechanism in the distributor automatically adjusts timing so that the mixture is ignited earlier. This gives the mixture time to burn completely during the power stroke.
The centrifugal advance curve on our distributors is carefully calibrated in production. However, if there's any reason to question the operation of the centrifugal advance, check distributor operation using a reliable test bench. Now, it's a fact that under part throttle and light load conditions, the air-fuel mixture isn't as highly compressed. The fuel particles aren't packed as tightly together, and it takes longer for the flame to travel from one particle to the next. As a result, under part throttle and light load conditions, the combustion process is slower, and the mixture must be ignited sooner so that all the fuel will be burned before the end of the power stroke. The vacuum advance takes care of this little detail. And if someone out there will take care of that little detail of turning the record,